Hello students, we have question express tan inverse cos x upon 1 minus sin x where x lies between pi by 2 to 3 pi by 2 in its simplest form. Okay, so before coming to that question, let's talk about the trigonometric function tan x. We can write tan x as sin x upon cos x, and here is the graph of tan x. So when we talk about the domain and range of the trigonometric function tan x, so it will take all the real inputs except where cos x is 0, where the value of cos x 0, except that it will take all the real inputs. So the domain of tan x will be all real number except x does not equal to 2n plus 1 pi by 2, because at these values the value of cos x is 0 and its range will be all real numbers. Let us look at the graph of tan x. As we can see that the curve we have at different values, this curve we have at different values. So for different values of x we have different values of y. So minus pi by 2 to pi by 2, as we can see that from minus pi by 2 pi by 2, at pi by 2 and minus pi by 2 the value of the graph become infinite, it will go upwards and downwards. So now when we talk about the inverse trigonometric function tan inverse x, its domain will become r. We just turn, if we turn this paper, so this will become the graph of tan inverse x. Okay, now if we talk about tan inverse x, its domain will become all real numbers. Okay, and its range will become minus pi by 2 to pi by 2, because tan x is not defined as pi by 2 and minus pi by 2, so we are taking here open interval. Okay, so when we talk about inverse function, that is tan inverse x, its domain will be all real numbers and range will be open interval minus pi by 2 pi by 2, and its principal value branch will become minus pi by 2 to pi by 2. Now let's come to our question, which is tan inverse cos x upon 1 minus sin x. The given question is tan inverse cos x upon 1 minus sin x where x lies between pi by 2 to 3 pi by 2. Okay, now we want to change this denominator 1 minus sin x into cos x. So let's multiply 1 plus sin x, multiply and divide the expression with 1 plus sin x and 1 minus sin x. So it will become tan inverse cos x 1 plus sin x upon 1 minus sin x 1 plus sin x. Now when we look at the denominator, it is of the form a plus b, a minus b, and the formula of this identity is a square minus b square. So we will apply this formula here. So it will become tan inverse, numerator will be cos x 1 plus sin x upon, we can write it as 1 minus sin square x. Now it will become tan inverse cos x 1 plus sin x. We know that sin square x plus cos square x is equals to 1. This is trigonometric formula. So if we look at this, we can replace it by cos square x. So it will become tan inverse, we can cancel this cos with this cos x, so it will become 1 plus sin x upon cos x. Now we know that there are some formula, that is cos x is equals to cos square x by 2 minus sin square x by 2. Also we know that sin x is equals to 2 sin x by 2 cos x by 2. So we will use this formula in this expression 1. So it will become tan inverse. Also we know that sin square x by 2 plus cos square x by 2 equals to 1. So we will use these three formulas in this equation 1. So it will become, we will replace 1 by sin square x by 2 plus cos square x by 2, and we will replace sin x by 2 sin x by 2 cos x by 2 divided by, we will write cos x by using this formula. So it will become cos square x by 2 minus sin square x by 2. Now here we can see that it is of the form a square plus b square plus 2ab. It is of the form a square plus b square plus 2ab. So we can write it as a plus b ka whole square. And this has taken the form a square minus b square. So we will write it in the form a plus b a minus b. Now let's solve further. It will become tan inverse sin x by 2 plus cos x by 2 whole square divided by cos x by 2 minus sin x by 2 multiplied by cos x by 2 plus sin x by 2. Now we will cancel out this with this. So we are left with sin x by 2 plus cos x by 2 divided by cos x by 2 minus sin x by 2. Now we will divide numerator and denominator by cos x by 2. Divide n and d by cos x by 2. So what we will get? We will get tan inverse. This will become sin x by 2 upon cos x by 2. So this will become tan x by 2, and this will become 1 upon, this will become 1 minus tan x by 2. And we can write it as tan inverse 1 plus tan x by 2 upon 1 minus tan x by 2. Now we know that tan inverse 1 equal to pi by 4. Place it here. So it will become tan inverse tan pi by 4 plus tan x by 2 upon 1 minus, here we can write it 1 into tan x by 2. So it will become tan pi by 4 tan x by 2. Okay. So now tan inverse, this is the formula of tan x plus y. We know that tan x plus y equal to tan x plus tan y upon 1 minus tan x tan y. So it will become tan pi by 4 plus x by 2. Now before solving this, let's look an important property of inverse trigonometric function, which is this property. Sin inverse sin x is x, where x belongs to minus pi by 2 to pi by 2. Similarly, we can write tan inverse tan x is equals to x if and only if x belongs to this interval minus pi by 2 to pi by 2. So what we get? We get tan inverse tan pi by 4 plus x by 2. This we got. We can write it only pi by 4 plus x by 2 if and if only we satisfy the property of inverse trigonometric function. And we have given the condition, this we have given that pi by 2 less than x less than 3 pi by 2. So we will check that if the input we are working on is satisfy the this property of inverse trigonometric function or not. So we will check it. We will divide both sides by 2, so it will become x by 2, this will become pi by 4, and this will become 3 pi by 4. Now we will add pi by 4 both sides to check if this output is in the given range or not. So it will become x by 2 plus pi by 4, and this will become pi by 4 plus pi by 4, so it will become pi by 2, and it will become 3 pi by 4 plus pi by 4, so it will become pi. Now we can see that the output we get x by 2 plus pi by 4 lies in the interval pi by 2 to pi, which lies between the given range. So we can replace tan pi by 4 plus x by 2 by pi by 4 plus x by 2, and this will become our answer. Thank you.